Okay, so this is Chapter 6, Sampling Distributions. So let's start. Number 1. In one state, it's known 30 out of every 100 individuals have a bachelor's degree. What's the standard deviation of the sample proportion for sample size 100? Okay, so 30 out of 100 is 0.3. So that makes our life easy here. Because then that would mean sorry, 0.3, 1 minus 0.3 over our sample size 100. Let's calculate that. And taking the square root is 0.0458. And there we go. Okay, let's make sure that's actually correct. It is. Number 2, when working with the sample mean distribution, what's the smallest sample size to ensure that the central limit theorem can be used? This is definitional. It's 30. So you'd see that in the chapter. Number 3, players have a mean weight of 225, standard deviation of 30 pounds. What's the mean and standard deviation if the sample size is 9? Okay. Well, the mean one should be easy. That one we should know pretty easily because we know that it will be about what the population is here, 225. So that one we don't need to worry about too much. But we do need to look at the standard deviation. So that would mean so 30 over the square root of my sample size 9, which is 3. So 30 divided by 3 is 10. So we're going to have to choose 2 options here. So I'm going to erase this now. So we know that the mean will be 225. And that our standard deviation will be 10. And there we go. And as I go through these, if there's something that's not making sense to you, even in my short video, just let me know and I'll try to make something longer for you to explain things better. Which of the following must be true if 84 out of 200 enroll in a cell plan? Dude, this one's nice and easy. $84 out of 200. That's 0.42. Okay. Yeah, I like doing this now. Now I know that I'm actually giving you right answers. Okay. So let's look at the next one. Coin is flipped 64 times, probability at less than 45% on trials. So we need to find first what's 45% of 64. That's 28.8, so we're essentially looking for probability of x less than 29. So, that puts us at let's see here, 29 minus 32, right? Because 32 would be, if flipping it 50% of the time puts us, if it was completely fair coin, we'd have 32 times of getting tails, 50% of the time getting heads. So we're looking for that probability at the 45%. Okay, so let me look at the table here. Let's see here. Just give me 1 second here to find this. Right, so that would be using our chart. We're hopefully at 0.2119, and we are. So that was using the probability tables from the book. Number 6. X is mean value from random sample of 64 with mean of -20, standard deviation 2.4. Probability that we're going to be between -20.3 and 19.4. Okay, so let's just make sure here. So far we're good. Okay, so the biggest thing to do here, I guess, just to be careful about, is as we're solving this, we can't use the standard deviation of 2.4 straight. We need to adjust that for the fact that we have a sample size here. So one kind of background equation we need to do here would be so in this case it would be 2.4 over square root of 64, and that is 0.3. Okay, so now let's go back to here. So now it's going to be -20.3 minus -20 over 0.3. So that's equal to -0.3 over 0.3. So that's equal to -1. Now let's do it for the other side here, 19.4. So that'd be 19.4 minus 20 over 0.3. So that leaves me with 0.6, sorry, minus -20, 0.6 over 0.3, which is 2. Okay. So for a z value of -1 is 0.1587. That's our 587. There's our probability there. And for 2 on the table, it's 0.9722. Subtract these two. And we have an answer here of 0.8185. Let's make sure that that's correct. Okay, let's turn to number 7. Which of the following will be normally distributed? So here, we're obviously our ones that are normally distributed populations. We know that those will be. But also we know that this should be large enough, skewed left population. Our sample size should be large enough that we should still be okay. I think, yeah, and there we go. So it's obviously our two normal distributions, but also we have a skewed left with a large enough of a sample size to conclude that it's also normally distributed. Okay, now I am making ball bearings. So if the mean is 10, we're basically looking to make sure that we're going to fall in the range of 9.1 to 10.1 because I want to be within 0.1 of that diameter. So, let's go to our table here. So I'm using it with 9.9 first. And then I'm doing it with 10.1. And subtract the 2. Okay. And so using the cumulative probabilities and subtracting. And if you're looking in the book, this is a lot like example 7 on page 182. Okay. Oil change center. Driven more than 3,600, so it's going to be 3,600 minus the mean of 3,500 over we gotta do these, sorry, we gotta do this here. We got the standard deviation of 400 divided by the square root of the sample size, which is 100. So that would be 400 over 10, which is 40. Let's put 40 here. So we'll have 100 over 40, which is equal to 2.5. On the cumulative distribution, that leaves me with 1 minus 0.9938, which which is equal to 0.0062. Hopefully that's correct. It is. And our final one. Mean height of 64, standard deviation 2.4, random samples of size 16. Oh, well, this one should not be too difficult. Because we have enough random samples, the mean would be the same. So we should still be at 64. Yep. Okay. That does it.